Hi, I'm Cristina. I'll talk about immunizing systems from distant failures by limiting Lamport exposure. This is joint work with Bryan. Here are Alice and Bob. They're working on a document. They might be in the same office buddies, or at different locations around the world. Alice might think that the document updates take the shortest network path, which would be super fast. Failures outside this path cannot affect Alice. And can we really blame her for thinking that? She's living the cloud dream, which means that no matter where you are, no matter when, you're gonna be able to access your documents. Of course, we don't store just one copy of this document. There are multiple replicas. That's because we want to be resilient to failures and we want to be fast. Still, Alice cannot have at the same time strong consistency, which means she sees Bob's latest updates, availability, and be resilient to partitions. But don't worry, partitions are rare events in cloud systems, right? And they're also unlikely to happen in the internet. So most of the time, Alice should get both strong consistency and availability. And geo-replication should be sufficient, so Alice should still live the dream. As I'll show later, geo-replication is actually insufficient. But above all these expectations and theories, it's facts that rule. And they might burst Alice's bubble. Just last year, there was a switch that exhibited a very short-lived failure in Cloudflare. This cascaded into a few hours of downtime. And a few months ago, a customer of Fastly, a CDN, updated his configuration. This triggered a bug that led to downtime for the entire CDN. And partial network partitions can trigger software bugs. Users are likely annoyed and perhaps even angry. Is this fair for Alice? And is it responsible from the system's designer's part to expose her to global failures? If we decide that we're not okay with that, how should we change our system design? Perhaps this shouldn't come as a surprise, because as Leslie Lamport famously said, a distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. Can we do something better for Alice? Can we protect her from failures on the other side of the world? I have spoken about users being surprised by faraway failures. I'll continue by defining Lamport exposure, which is our approach to shield users from remote failures. I'll give some metrics for Lamport exposure, and I'll go over the challenges to apply it. I'll briefly go over Limix, which is our approach to apply Lamport exposure to naming in a distributed system. Preliminary results show that this is a great opportunity. Alice's Lamport exposure is given by the set of all distributed system components. These could be servers, routers, network links, and so on, that could make her access fail or be slow. So for example, when Alice wants to fetch Bob's updates, her exposure is the size of the bubble that includes Bob and all these elements. And in general, as we've seen in recent events, this exposure is some global set that Alice might not even be aware of. Our goal is to decrease Alice's Lamport exposure. Alice gets more meaningful exposure when interacting with Bob, with two consequences. She's aware of the exposure, but also as Bob gets closer, the exposure gets smaller. This is also true for Alice's future collaborators. For example, with Charlie, she will also get a meaningful exposure bubble. I'll continue with metrics. In practice, it might be hard to count all these distributed system elements to measure exposure. So instead, to measure the size of this bubble, we thought of a few metrics. We could use natural administrative or legal boundaries. For example, for data sovereignty, it's useful to have a zone inside the EU and one zone outside the EU. For blockchain transactions, it's useful to have a common legal framework. Geographic distance, that's useful for news blogs. Round trip time, that's useful for time-sensitive applications like gaming and voice calls, or network hop count. That's because paths with fewer hops are more resilient. Challenges. Why is it so difficult to shield users from remote failures? Alice uses an application to edit the shared document. And so not only will she have dependencies to pull Bob's updates, but at a higher level, her interface might want to pull icons from everywhere. And at a lower level, her request might cross the public internet. And they're gonna cross network elements as BGP dictates. Of these many layers, we focus on one specific problem. How do we find something local when the naming system is usually global? Limix. I'll start with Geo-replication and why it's insufficient. I'll continue with strawman before getting to our approach. Take a look at the figure. There are two documents geo-replicated in the areas where they're accessed most. The challenge is to be able to locate these documents without leaving the area. So normally we use a discovery service that has pointers to the documents. But the user here is just unlucky. The document is looking for is in the user's area, but it needs to go outside the area to query the discovery service. And no matter where we place the discovery service, there will always be some user in some area that's unlucky. And the problem is that the system needs a known entry point for the discovery service. Otherwise, it wouldn't be able to locate the discovery service itself. Strawman. Instead of one discovery service, we can replicate the discovery service in all areas. Now, the user just needs to query its local discovery service to find any document, both document 1 that's inside the area and document 2 outside. But the issue now is that all these discovery services store pointers to all documents. And so whenever we update a document, we need to update all discovery services, no matter whether any user needed to locate that document. And so that's a huge overhead. Strawman 2 fixes this problem. We'll have local discovery services store pointers only to local documents. Then how does the user find a document outside the zone? Well, we're gonna have a global discovery service storing pointers to all documents. This lives in a global zone that overlaps all other zones. And so user first queries its local discovery service. If it can't find a document, it means the document is outside the area, so it queries the global zone. The additional advantage is that a zone only serves load for documents that live in that zone. The remaining challenge is to support finer-grained zones, not just local versus global. And that's what Limix does. Limix creates as many zones as necessary. The trick is that every zone is going to have a discovery service with pointers just to zone documents. How well does all of this work? We made an experiment. We created some zones and then deployed the system along these zones. Note that we create the zones before knowing who the users are and what their interactions might be. The challenge here is that we want to create as few zones as possible because zones use resources. But then we want to limit the exposure for all users. And so we test that. We take a random test area and then we disconnect it from the rest of the world. The question is, can random users in this test area interact successfully? We deployed Limix on CockroachDB, and here are the results. The x-axis shows the diameter of the test area. Of course, we have experimented with many random test areas. You can see that before Limix, small test areas have almost zero success rate. After Limix, the success rate improves in most cases to 100%. There are more things in the paper. For example, how to maintain strong consistency during data migration, and also how to do efficient auto-zoning that bounds the resource usage. In conclusion, nowadays global distributed systems expose users to global failures. That's unacceptable. We have defined Lamport exposure and proposed metrics for it. Limix is our approach to limit the exposure of a naming component in distributed systems. And our preliminary results show that it's possible to bound exposure for all pairs of users without insurmountable costs. Thank you. I'm happy to take questions.